So let us see. Okay, let us see this slide. This slide will tell you that what kind of data is required for correlation coefficient. For correlation coefficient, we require bivariate data in the form of xi, yi. So first pair is x1, y1. Second pair is x2, y2. Third pair is x3, y3. And so on. Last pair, nth pair is xn, yn. Once we have this data, we do calculation xi square, yi square, and product xi, yi. These are the basic calculations we require. After this calculation, we perform totals, summation xi, summation yi, summation xi square, summation yi square, and summation xi star yi. All these 5 totals will give you 5 computations. Summation xi will give you mean of xi, mean of x. Summation yi will give you mean of y. Summation xi square will be used for variance of x. Summation yi will be used for variance of y. Summation xi yi will be used for covariance between xi yi. And once you have covariance and variances, coefficient of correlation is very easy to obtain. It is the covariance divided by square root of variances. And so we need a data xi, yi. When I write x1, x2, xn, it is an array. When I write y1, y2, yn, it is an array. So I have to define array. I have to do these calculations. So if you understand this, we will write the program for correlation coefficient. So I will ask Asta Doshi to share her Turbo C screen. Asta Doshi, share your Turbo C screen. Well, Asta Doshi have shared Turbo C screen. And now we will go on writing the program. So let us see. Let me define first, say integer variable, say int. int. How many observations are there? Say n. Comma. I need a counter going from first observation to second observation to third observation to nth observation. So it is I, semi-comma. Now I will define float. Float. Say x bracketed 10. X bracketed 10. Comma, y bracketed 10. Y bracketed 10. Now remember, we want to do a lot of calculations. So semi-comma, sorry, comma, sx. Sx, or you write, okay, sx, this is for sum of x. Sy, for sum of y. Sx2, for square, sum of the squares of x. Similarly, sy2, sum of the squares of y, comma, sx, comma, Sxy, sum of the product of xy, comma, mx, mean for x, my, mean for y, vx, variance of x, vy, variance of y, cxy, covariance, comma, r, that is correlation coefficient, r, semicolon. See, these many variables I have to declare. And I think there is no difficulty in defining these variables once you understand the table and the calculations thereafter you have to perform. Now, as usual, we have to initialize Sx, Sy, Sx2, Sy2 and Sxy by 0. So initialize Sx equal to 0, semi-comma, Sy equal to 0. You may write it in one statement only. Sx equal to 0, Sy equal to 0, Sx2 equal to 0, Sy2 equal to 0, Sxy equal to 0, semicolon. These are the initializations. Remember, these are the initializations. Come to the next statement, CLR, SCR. CLR, SCR. Now, how many observations? Printf, printf, in bracket, double inverted comma, backslash n, enter the size of the data, capital small n equal to, enter the size of the data, size of the data, n equal to, double inverted comma complete, bracket complete, semicolon. Right, now scanf, scanf, percent n is declared as integer. So percent d integer, comma, and n. Okay. So this is the size of the data. Now I have to collect the data from keyboard, and I have to perform the calculations. So I will write for I equal to 1, comma, semicolon, semicolon, I less than or equal to n, semicolon, I plus plus, bracket, come down and write down curly bracket. In curly bracket, write down CLR, SCR, CLR, SCR. Okay. Now below that, write down printf, printf in the double inverted comma, double inverted comma, enter, enter the enter the value of x bracketed percent d, x bracketed percent d, and y bracketed percent d, double inverted comma complete, comma, I comma I, bracket complete, semicolon. I comma I because I have used here percent d, percent d. So I will get the message, enter the value of x1 and y1, enter the value of x2 and y2, enter the value of xn and yn, like this. So scanf bracket double ended comma %f complete, yes, comma, and xi xi is not like this. Okay, now this is only for xi. We have to write one more statement for yi. So write down another statement for yi. Scanf, not print, because print is already there. Scanf yes. Now once you take the value of xi and yi, you have to update sx, sy, sx2, sy2 and sxy. So write down sx plus equal to sx plus equal to xi. This is what assignment state, xi okay, semi-comma. This is the assignment statement we have learned. Now similarly, update all the equations sy, sx2, sy2, sxy. How x2? It is xi star xi. X2 is wrong. Xi star xi. You are squaring. Remember what kind of calculation you are doing. Xi star xi. Yes. Srutika. Bankar.
Sorry, sir. It's mistake.
Right. So this completes the calculation. And now we will close our curly bracket. For curly bracket. Curly bracket corresponding to for, we will close it. Okay. Now after completion of this for loop, sum of x, sum of y, all these calculations are ready for us. So we'll calculate now mx, my, vx, cx, y, and r. So write down mx equal to sx upon n, sx slash n, semicolon. In the same line, you can write my equal to right. So these two calculations will give you mean of x and mean of y. Now we'll go for variance of x. So vx equal to sx2 upon n, summation x square sx2 slash n, minus mx star mx. Recall the formula for variance mx star mx. Write down similarly for variance of x. Right. Now we'll go for covariance cxy. Cxy equal to sxy upon n minus mx star my. Mx star my. Semicolon. And now last calculation remains is r. R equal to cxy upon slash in bracket or write down square root sqrt in bracket vx star vy, because we want standard deviation vx star vy semicolon. Now last is the output printf correlation coefficient is r equal to %f double into comma complete comma r bracket complete semicolon get ch and close the main curly bracket. Okay. Now here we have used sqrt. So we have to update include statement by math library. Come to the include statement and add hash include math.h. Hash include math.h. Now let us see whether we are correct or not by compiling this program. Success. So run this. Let us say data size 5. Enter. See here, enter the value of x1 and y1. So give the value of x1, say 23. Enter. And now you have to give the value of y1, say 25. Enter the value of x2, y2, so 29. Enter 35. Enter the value of x3, y3, say 62. Enter 75. Give some values. Enter. Correlation coefficient is r equal to 0.671011. That's right. So come back. So this is save this program as correlation. Save this program as correlation. Save this program as correlation. Okay. So this is the program for correlation coefficient, right? Quite big program, but very interesting program. All right. Now you are free to ask difficulties because many of you are writing the programs, but